This video is on dilations. It says here that we are going to assume that all dilations and transformations have a center at the origin at 0, 0. So number 1 through 4 says to write the rule that illustrates the transformation. In number 1, we have a dilation by a scale factor of 5. When you have a dilation, your x and your y are both multiplied by that scale factor. So your new one here would be 5 times that x and 5 times that y to show the dilation. In number 2, we have a horizontal stretch of 4. Now horizontal stretches and shrinks, they're not dilations, they're different. To be a dilation, both the x and the y have to be multiplied by the same factor. So technically speaking, this is just an extension, but it is not a dilation. So with that said, if we're stretching something horizontally, we're affecting the horizontal axis known as the x-axis. And so we're going to affect the x variable. So we're going to take our x and our y, and to stretch it horizontally, we're actually going to just stretch it by doing 4 times the x, but the y is left alone. And number 3, we have a vertical stretch of 6. So this time we are affecting the vertical axis, we're not affecting the horizontal. So if it's the vertical axis, we're talking about the y-axis. And when we vertically stretch along the y, we affect the y. So the x stays the same, but the y will be 6 times the value to make it a vertical stretch. On number 4, we see a horizontal shrink of 1/5. And so when we look at that, again, it's horizontal, affecting the horizontal axis, which we're talking about the x-axis. And it's a shrink just because that number is between 0 and 1. And so what we'll do is take 1/5 of the x and we'll leave the y alone. So one more time, let's review. The only thing that is a dilation in this first section here is the one in which both x and y are multiplied by the same scale factor. The remaining ones of these, they're a transformation, but they are not a dilation. Numbers 5 and 6, it says that we're going to graph the transformation. So in number 5, we did a dilation of a scale factor of 1/3. To do that, what you want to do is you want to take your j, which is at -3, -5, and you want to take your k, which is at 3, -1. And what we're going to do is we're going to multiply both the x and the y by 1/3. When we do 1/3 of -3, that's -1. And when we do 1/3 of -5, that's -5/3, or otherwise known as -1 2/3. For the k prime, we're going to multiply both of these by 1/3 as well. 1/3 of 3 is 1, and then 1/3 of -1 is -1/3. So we'll do our best to plot these points here. And so we're going to plot the point -1, comma, -1 2/3, so right about here is going to be where my j is. And then we're going to plot the point 1 and -1/3, which is right about here. So we're going to connect those. This is called J prime, this is called K prime, and there shows our dilation. This one is an example of a reduction. Alright, on number 6, it says we're going to do a horizontal shrink by 1/2. And so let's go ahead and take our A, which is at -2, -1, and our B, which is at 0, 4, and we're going to shrink this by 1/2, but only horizontally, which means only the x is getting multiplied. So here we're going to take our a, which is at -2, -1, we're only going to multiply this by 1/2. When we multiply this by 1/2, that is going to give me -1, and we leave the y alone. When we multiply this x by 1/2, we're going to get 0, but we leave the y alone. So now let's go ahead and plot these points. We're going to plot the point -1, -1, and we're going to plot the point 0, 4. And so this is A prime, this is B prime, and when we connect that, that is your horizontal shrink.